All right. So welcome everyone. This is the IARPC Atmosphere Collaboration Team meeting for the month of December. My name is Andrew. I am a member of the IARPC Secretariat. Really excited to have everyone here today, and particularly our wonderful speakers who have agreed to be here. So before we get started, a few ground rules. If you are not actively speaking, please keep yourself on mute. We ask that everyone treats each other with respect, and during this month's meeting, if you do have questions during the presentations, please save them for the end. You can also put them into the chat, and we'll make sure that those get asked of the presenters. However, we aim to have a good chunk of time at the end just for general discussion, some question and answer session, and any announcements that community might have. So I think what we're going to do this month is do an oral roll call. So if you could please just state your name, affiliation, and if it's your first time at an IARPC meeting. So I think I wanted to introduce myself. Heis will be helping me kick off this meeting. So Heis, would you like to go next?
Sure, happy to. Do you want me to do the general meeting introduction now too, since we're kind of moving that way? Sorry, you were muted, but I'm going to assume you said yes for now. So, yes. Hi everyone, I'm Heis Wilbourn. I'm a research scientist at the University of Colorado and one of the IARPC Atmosphere Collaboration Team co-leads with Colleen Hafke and Barry Leffer, who's not here today. But thank you all for joining the meeting today. It's one that I look forward to every year because we've done this for the last 4 years, I believe, where the meeting that we have right before AGU, we invite people to come to give a sneak peek of what it is they're going to be talking about. And it's not meant for you to give away all your key results and secrets, but hopefully a way to kind of draw more attention to your talk or poster or town hall or whatever it is that you're sharing with us. And also just to provide some community awareness to the types of projects that are being undertaken by all of the Arctic scientists that we work with. So thank you all for being here, and I will hand it off to Colleen, and then Drew, maybe you can call out names beyond that so we have an order to things. Thank you.
That sounds great.
Hi all, I'm Colleen Hafke. I am a program director for the Arctic Natural Sciences program at the National Science Foundation, and recently added co-lead for the Atmosphere Collaboration Team. So I'll echo Heis in thanking you all for taking the time to present today. I'm looking forward to hearing all your presentations.
Great. I will now just kind of go in a somewhat random order. Sarena.
Hi, everyone. I'm Lieutenant JG Sarena Padilla at the U.S. National Ice Center, based outside of Washington, D.C. I work on the Navy side of the house. For those that don't know, the National Ice Center is a tri-agency between the Navy, U.S. Navy, and NOAA, and the U.S. Coast Guard. And I serve as a science officer here, and I look forward to hearing everything.
Excellent. Thank you. Radiance Calmer.
Hello, Radiance Calmer. I'm a postdoc at the University of Colorado. I'm working with Heis and Gina on the MOSAiC project, and I am really happy to hear today about all your science.
Great, thank you. Jingfeng Wang.
My name is Jingfeng Wang. I'm working at the Georgia Institute of Technology Department, a School of Civil Environment Engineering. So most of my research is focusing on modeling heat mass exchange between Earth and atmosphere.
Thank you. Patrick Taylor.
Hi, everybody. Happy to be here today. I'm Patrick Taylor from NASA Langley Research Center. I'm a senior research scientist there, work primarily with radiation budget, and I'm looking forward to hear everybody's presentation today. Thanks.
Great. Elin McIlhattan. Apologize in advance. They might be off mute. That's okay. Gina Jozef.
Hi, can you hear me?
Yes.
Okay, awesome. Yeah, I'm a PhD student at the University of Colorado Boulder, studying in the Atmospheric and Oceanic Sciences Department. I work with HEISS and Radiance, as Radiance had mentioned, on MOSAiC data.
Thank you. Elise Wilbourn.
Hi, I'm Elise Wilbourn. I'm a postdoc at West Texas A&M University, working with Naruki Hiranuma on aerosol and ice nucleating particle measurements.
Janet Intrieri.
Hi, I'm Janet Intrieri. I'm an atmospheric research scientist at NOAA's Physical Sciences Laboratory in Boulder, Colorado. And I am also the co-lead of the sUAS collaboration team.
Excellent, thank you. Anya Jones.
Hello, I'm Anya Jones. I work in the Department of Aerospace Engineering at University of Maryland. I'm a fluid dynamicist, I'm a steady aerodynamicist, and just generally looking to learn a little bit more about Arctic science. So just lurking, if that's all right.
Of course, glad you're here. Steve Vavrus.
Steve Vavrus. I'm a senior scientist at University of Wisconsin in Madison, and it's our first cold day of the winter, and hence my Icelandic sweater. My areas of expertise are climate modeling and global climate change, including the Arctic.
Excellent. Neil Barton.
Yeah, hello, I'm Neil Barton at the Naval Research Lab in Monterey, California. I work on global coupled modeling with focus on coupling in the Arctic region. I will not be at the AGU, but I'm looking forward to.
Excellent, thank you. Nate.
Hi there, yeah, this is Nate. I'm at the University of Wisconsin in Madison as well, working with Tristan Lecuyer on pre-fire, and not my first IARPC meeting, but it's been quite a while, so I appreciate this meeting today as I've look forward to the talks.
Great, thank you. Last, Greg Anderson.
Hi, everybody. I'm Greg Anderson. I work with Colleen Hafke in the Arctic Sciences section at NSF, and I'm just here to listen in. I'm looking forward to hearing the talks.
Great.
And I don't know if Ellen can try again.
I'd like to try again. Can you hear me this time?
Yeah.
Oh,
Yes.
great.
Hi.
So sorry about that. I'm Elin McIlhattan. I work at the University of Wisconsin-Madison as a postdoc, working with Tristan Lecuyer on clouds, precipitation, radiation in the Arctic. And this is my first IARPC meeting.
Have some of the first timers as well as all the presenters. Heiss, is there anything else you want to say before I start the presentations here?
No, not really. I'm excited to see these
you're muted.
slides.
Nice.
I'm not muted. Can you hear me now?
Yes.
Yeah, okay. There is something weird with the audio because you were muted initially as well, Drew. So we might have to give people a little grace period as they unmute themselves, and at the same time, Zoom still thinks they're muted or something. So I don't have anything further to say. I'm looking forward to the slides, and let's jump in.
Excellent. So I did paste the agenda and speaker order in the chat if you would like to refer to that. Otherwise, I think up first we'll have Patrick Taylor. So I'm going to just get this to full screen. And I'm not going to rigorously enforce our 2 to 3 minute talk, since I think we'll have a good amount of time, but just keep that in mind as you're speaking today. Thank you.
We'll do eliminating me to a single slide. We'll cut the length of the talk down quite a bit, but thanks again for the opportunity. I'm here to introduce this IARPC joint US CLIVAR IARPC town hall on understanding the coevolution of the atmosphere, sea ice, and ocean in the new Arctic. And this is work with organizing with a bunch of other folks, including HEISS de Boer, who's on the call here, Fred, Lynette, Marika, and Anna all made, and Patrick of Heibach made some great contributions to this. So our motivation behind the town hall is that the value of Arctic predictions are increasing. especially in the region, especially due to the increased climate vulnerability and the economic activity in the region. And there's a gap in our understanding, which is the atmosphere sea ice ocean coupling. And if we could close this gap in understanding, we could really realize more of the full potential and value of these predictions. So the goal of our town hall is to get these tangible joint actions that US CLIVAR and IARPC can do together to help advance our understanding and reduce uncertainty in these in Arctic climate change projections. To help us with this, what we've done is put together a questionnaire, which we have 40 responses to so far. And I'm going to paste it in the chat when I'm done. So anybody else on this call, please take the questionnaire and fill out and provide your inputs to this. So you don't have to be at AGU in order to provide us your inputs on what actions CLIVAR and IARPC can take in order to reduce, make strides in this area. So the plan for the town hall is to share our questionnaire results and then to present draft recommendations, which we have a few, but I wasn't planning to share in a 2-minute time, and then to gather more input on these to make sure this is the right right input, the right recommendations, and to make sure nothing falls through the cracks, essentially, so we can make a plan going forward. So with that, I'll stop talking, but looking forward to those who can participate either in person or virtually. And if you can't do either, please fill out the form that I'll paste in the chat right now. Thanks.
Thank you, Patrick. And I'll make sure that that Google link ends up on the IARPC event page too, for anyone who can't make today's talk. All right. So next, looks like we have Sarena Padilla.
Hello again, everyone. I'll be talking about our poster on the post-ISEX ice flow longevity. I also have Alexandra Darden, my co-author here. She'll be there for the Q&A session later. So to start off, the U.S. National Ice Center is a key player when it comes to operations in, on, and around the ice in the Arctic and the Antarctic regions. And with that, we provide support for safety of navigation of mariners in those regions and for scientific field campaigns that actually occur on the ice. And some of these campaigns can take place over multiple weeks back to back. And with cases such as those, they set up an ice camp on an ice flow that drifts over the several weeks of the campaign. And we need to have knowledge of the environment of the ice in order to choose a suitable ice flow for the field campaign in the first place and make sure it lasts throughout the scientific mission or whatever the research is trying to obtain from the ice. And one of these missions, probably our biggest one that we support from the U.S. National Ice Center, is ISEX, or ice exercise. And this occurs every 2 years, and we provide support in the planning. And this research looked at the post-ISEX ice flows, and we specifically looked at the previous ISEX years of 2018 and 2020 with the imagery that was archived from RadarSat-2 and Sentinel-1. And we followed the ice flows in the post-ISEX timeframe, so end of March and beyond, in order to look at their surface melt or how far they drifted away from the coastline of Alaska, if they were outside of air support, for example, outside of a 250 nautical mile radius of Deadhorse. And those are just things we have to consider when choosing the ice flow for the ISEX mission. And I will probably leave it at that and leave you wondering more for the poster, honestly. And also on the poster, we go over more of the National Ice Center's support that we provide for ISEX and some of the products that go along with ISEX. So thank you.
Great, thank you. Up next, looks like we have Radiance Calmer.
You might have heard about MOSAiC already, particularly from HICE. So this study is focused on the albedo of the surface and the meltdown fraction. So the helix, the copter that you can see at in the picture on the top left, can actually close the gap between what we currently call like traditional measurements, like ground-based measurements that are like 1 or 2 meters above the surface, and then more airborne measurements like helicopter that would be above 100 meters. And with the helix, we can be very close to the sea ice or profile up to 400 meters. So the measurements we do are with 2 pyranometers mounted on gimbals, and then a multispectral camera. So one of the flight type we have is profiles, and in the figure in the center, you can see that we started profiling above different feature on the sea ice. So the profiles in blue started with the copter above melt pond, and then going higher up to 100 meters. And then the profiles in red started above like more snow, bare ice surface. And what is interesting in these profiles is we see that as we go higher in altitude, there is a kind of a convergence and emerging altitude. To identify this merging altitude, so that's the second figure at the bottom, we took the first profile above melt pond, and then we subtracted it to the profile above snow. And you can see the red curves correspond to the difference between profiles started above different kind of feature, melt pond or snow. And we obtained a kind of a very consistent merging altitude around, so between 50 and 55, so 52 meters. And the blue curve corresponds to a difference between 2 profiles started above melt ponds. So the merging altitude would correspond more about like differences of the feature of the sea ice. To give you an idea, the picture at the bottom left corresponds to the multispectral camera image at 100 meters, and we can obtain an estimation of the melt pond fraction on this image. And the melt pond fraction varies for this kind of flight between 31 and 30%, to have a first idea. This is just the first analysis we can conduct with the profiles. We also have survey from the helix that would give us like a high resolution of albedo distribution over the surface. And we can also investigate the temporal evolution as we flew through the melting season. And then hovering flights, so flights at very low altitude, would provide more information about specific features like melt pond, bare snow, or even open ocean. And that could be linked to the convergence height with the profiles. So I would be happy to discuss about the helix data and to see you during AGU. Thank you.
Great, thank you. Up next, we think we have Gina Jozef.
Yeah, hi, my name is Gina Jozef. In my poster and e-lightning talk at AGU, we'll cover my work quantifying the atmospheric boundary layer, low-level jet, and temperature inversion characteristics over a year in the Central Arctic during the MOSAiC expedition using small uncrewed aircraft system and Radiosonde data. The motivation behind this work comes from the fact that the Arctic is warming at a rate at least twice as fast as the rest of the planet, as I'm sure we all know, and this trend is expected to continue. This enhanced warming occurs as a result of changes in the surface radiation budget, which is affected by different atmospheric processes. In this study that I'll present at AGU, we quantify 3 primary features of the lower atmosphere: the atmospheric boundary layer, low-level jets, and temperature inversions, and show how their occurrences and characteristics correlate to each other using data from the MOSAiC expedition. So MOSAiC, maybe we all know, but just to refresh, if you don't, it was an expedition in which the icebreaker Polarstern was frozen into the sea ice pack and set to drift across the Central Arctic for an entire year from October 2019 through September 2020. So the data used in this study comes from 2 platforms, the Radiosonde and the Datahawk 2 uncrewed aircraft system. The locations of all Radiosonde and Datahawk 2 flights along the MOSAiC drift track can be seen on the map of the Central Arctic in the top left of this slide. And below, a picture of each platform is shown. So during MOSAiC, the Datahawk 2 was deployed during legs 3 and 4, which spanned from March through July of 2020. And the Radiosondes were launched at least 4 times per day over the course of the whole year. So using the Radiosonde and Datahawk 2 profiles, we quantified 3 atmospheric features. First, the atmospheric boundary layer height was determined using a Bulk-Richardson number-based approach, which is demonstrated with the profiles of virtual potential temperature and Bulk-Richardson number. Next, a low-level jet was identified as a wind speed maximum that was at least 2 meters per second greater than the wind speed minima above and below, which is demonstrated with the profile of wind speed. And lastly, a temperature inversion was identified where the temperature gradient exceeds the threshold of 0.65 degrees Celsius per 100 meters, and that's demonstrated by the profiles of temperature and temperature gradient. Additional metrics relating to these 3 features, such as stability regime, low-level jet speed, and inversion strength, among others, were identified. So the results of this work are going to be presented in 3 ways at my AGU poster. So first, we're going to visualize the median and range of the boundary layer, low-level jet and temperature inversion height by month using box and whisker plot. Next, we identify where there are significant and strong relationships between different variables, for example, boundary layer height versus low-level jet speed. And we'll visualize this using scatter plots and linear regression. And lastly, we'll provide a table that lists summary statistics of different features, such as the average height and frequency of different characteristics. To see these results and the conclusions of this work, as well as what the future work is planned to expand upon this, please come to my e-lightning talk and poster on Friday, December 17th during session C52C, and that starts at 9:45 a.m. Central Time. Thank you.
Great, thank you, Gina. Up next, we have Jingfeng.
Oh, hi. You can see this is the poster I'm going to present next week at AGU. Although this is not about any topic related to the Arctic process, but actually, as I mentioned earlier, one of my focus of recent work is on modeling heat and water exchange fluxes over Arctic sea ice and snow surfaces. These 2 works are related. Here is the main idea of this study is a so-called non-gradient model of gas fluxes. So as we know in the classical method, the flux is always related to the gradient of some entity variables like temperature, concentration. So this new model does not use the gradient variable as input to calculate flux. So here we developed the model of using single level gas concentration to compute the gas fluxes. So as you see here, so the flux can be expressed as a time series record of single level gas concentration. So that's the idea. An additional, another important feature of this so-called non-gradient model is that the eddy diffusivity parameter is expressed in terms of sensible heat flux instead of the classical, the usual wind speed and the roughness. The motivation is to avoid using those data that are not easily collected by remote sensing platforms. So the details is not important at this point. If you go to AGU, you're welcome to stop by. I could tell you more about this so-called non-gradient model. So as you see, if you look at the result of the simulation using the model of the water vapor and CO2 fluxes from the land surface, actually. So you can see one of the obvious feature, look at the result on the right column is for CO2 flux. So this model can capture the nighttime flux very reasonably accurate compared to even the EC measurement, as we know. EC sensors have a hard time to capture nighttime flux for various reasons. For those doing field work in this topic, this is a well-known fact. So anyway, so this is the poster I'm going to present next week at AGU. I want to emphasize here is that I want to possibly collaborate with all of you on the Arctic research, especially the modeling energy budget models of over sea ice and the snow, using especially the MOSAiC. I'm very excited about the upcoming MOSAiC data product to use for testing the new models, so also called a non-gradient model of of energy budget, sensible latent, and also conductive flux through the snow and the ice layers. So I will leave it there.
Okay, great. Thank you for that. Up next, we have Elise Wilbourn.
Hi, yeah. So I am presenting results from 2 different field campaigns. One, we collected samples at Graciosa Island in the Azores, and then the other sampling site was in Ny-Ålesund, which is technically on Svalbard, but I think it's part of Norway. So we were measuring aerosol concentrations and specifically looking at ice nucleating particles, which are a specific type of aerosol that can change cloud properties that include the lifetime of the cloud, the albedo, and the amount of precipitation that comes from that cloud. And we did a couple different things. We measured INPs for at least 180 days at each site. We collected aerosols on the filters. And then we also subjected those aerosols to heat with the idea that heat would degrade proteinaceous aerosols and leave behind non-heat labile organics and other non-heat sensitive material. So overall, we found surprisingly that the INP concentration that's active at temperatures above -20 at the 2 sites is basically the same. But that the INPs from Graciosa Island are a lot less heat labile, especially at temperatures, freezing temperatures below -20. And we have a time series you can see there on the lower, with the 4 different colored dots. And then I also have just the median INP concentrations in the left-hand plot. So if you want to chat more, my poster session is Friday from 4 to 6, and I'm happy to talk.
Thank you, Elise. Next, we have Elin.
All right, can you hear me?
Yes.
Oh, good. All right. So I will be presenting a talk at AGU next week on work I've been doing with Jennifer Kay and Tristan Lequier. The title of the talk is Cloudier, Warmer, and Rainier, Exploring Changes to the Arctic Mean State in the Community Earth System Model version 2. So for anyone not familiar, the Community Earth System Model is a coupled global climate model that simulates Earth's past, present, and future that's really widely used amongst the Earth system community. And it recently went through a full renovation of all its coupled components and came out with version 2. And so the goal of this work is to highlight major changes to the Arctic environment because of this update. And to give away a lot of our results, we found that the Arctic in CESM2 is much cloudier, has much higher surface temperatures, and much more rain in the mean state. And so during the talk, I'll be using observations to provide context for some of these changes to say whether or not they're good, whether they're improvements to the previous, or whether there's still room to make it better. And so this plot I have here is just one teaser figure from our work to give an idea of what the magnitude of the differences are between these 2 versions. CESM1, the predecessor, is in red, CESM2 is here in blue, and this is Arctic total cloud water, and this is the annual cycle. So in the annual mean, CESM2 has almost 4 times more total cloud water than CESM1. So it is just a fundamentally cloudier Arctic than in the previous version. So I will leave it at that. If you're interested in any of these aspects, please attend the live session on Wednesday of next week, or have a look at the recorded talk that goes over it in detail. Thanks.
Thank you, Ellen. All right, I think this is our last talk. Steve.
So our project investigates the relationship between Arctic surface wind speeds and the influence of underlying sea ice concentration. And one of the motivations for this is if you look at the far left, the present day distribution of Arctic surface wind speeds shows a distinct marine minimum right over the perennial ice pack in the Arctic Ocean. And by contrast, flanking those are much stronger winds climatologically in the open waters of the North Pacific and the North Atlantic. We then looked at the CMIP-5 model simulations and their future projections out to 2100 with the strong RCP 8.5 forcing, and looked at, among other things, the seasonal changes shown in the far right panels. What you see is that the models are nearly unanimous in projecting a windier surface Arctic over the central or the Arctic Ocean, and these are especially pronounced in the winter and in autumn. But all seasons show an increase. And the second thing, well, I point out some of these increases are pretty large, up to 25% locally in winter. And the second thing to notice is the strong inverse relationship of these wind speed increases with sea ice changes. So where sea ice decreases in the future, you have the largest wind speeds. And you see that in every season, and even small scale features like this over the Chukchi Sea and Franz Josef Land areas of maximum ice loss correspond to these hotspots in biggest increases in surface wind speeds. So both the future changes and the present day suggests an inverse relationship between wind speed and ice concentration, and that begs the question why. And in our research, we explored two likely explanations. One of them is surface-based, that is that the ocean surface tends to become smoother as rough sea ice gives way to open water. And the other is atmospheric-based, and that being the drawdown of high momentum air as atmospheric stability weakens as the surface warms with ice loss. To test the relative influence of these two processes, we ran a supplemental simulation with the same CESM2 climate model we just heard about. In this case, we artificially smoothed the ice surface. So wherever there was sea ice, we imposed the drag coefficient or the roughness to be that of underlying open water. So it short-circuited the first process here of sea ice transitioning to smoother open water. And then we ran the experiment out to 2100 and compared the projections between the control run, the CESM large ensemble, the left map, versus our smoothed experiment in the middle, and looked at the patterns and magnitude of the wind speed changes. And what we found is that in both experiments, there is the expected wind speed increase in the future, but the magnitude is considerably less when you short circuit that first process. So in the smooth experiments, we found that the increase in surface wind speeds were about 40 to 70% magnitude of those of the control run. And so our preliminary conclusion is that these two processes identified here are roughly equal in being responsible for the projected increase in surface wind speeds in the future. And if you want to learn more, the poster presentation is the very last afternoon session on Friday from 4 to 6.
Thank you, Steve. And I'd like to just extend thanks to all of our presenters today. Really value your time to come and give us a little taste for what we can expect next week. I think before I hand it over to Heist to kind of run a little discussion question answer session, I believe Radiance had a kind of an announcement in general. We can do this now, Radiance, or we can do it at the end. I just thought might as well get it over before we devolve into conversation.
Thank you. So during the MOSAiC expedition, we were starting to discuss about the impact of the expedition on the environment. And then after the expedition, we started a discussion group. And until now, we have been working on 3 different aspects. With the primary work right now is to publish in the scientific literature an environmental impact report based on the MOSAiC expedition. And the idea would be to, for future expedition, particularly in the Arctic, to help to better plan some aspect of the logistic to minimize the environmental impact. We are also discussing on other topics. And we would like to meet in person during AGU. And we would be really interested to hear from your experience from outside of the MOSAiC community, but still with some Arctic experience. We are currently focusing on field work, and we have like different groups working on that, but we would like to really broaden our topics. So we are still looking for a place and a time to meet. But if this topic about sustainability in science is something you would like to provide your input or even like participate in the action that we are doing, please contact us, and we will make sure that we can meet and we can hear what you want to share. So yeah, thank you very much.
Thank you for that. And I'll make sure to also post this information on the IARPC event webpage for anyone who wants to have that after today's meeting. Okay, great. With that, I'll just pass it over to Heis, just so that we can kind of open it up for any questions and discussion.
Great, thanks, Drew, and thanks everybody. I appreciated all the slides and the content that was conveyed to the group. I think it was interesting to me to see that all of these slides kind of lived at the interface in some way between the ice and the atmosphere and the ocean. I know some of those connections are a little bit more abstract than others, but I think in general you can draw lines between all of the presentations at some level. Before we get into a broader discussion, I wanted to thank Radiance for the announcement at the end there, and I also wanted to remind the group, I know we have some regular meeting attendees here as well as some people who are new, but this is a good forum for making general announcements about Arctic atmospheric topics. And so I do encourage people to hopefully join us at future meetings as well and share whatever news you might have. The other thing I wanted to just check in about, for those who did not present a slide, if you have something you'd like to say about AGU or have a slide-less introduction to what you're planning to present, we're happy to hear about that at this point. And it's also okay if not, so we don't want to put anyone on the spot, but clearly if there's somebody who's like, oh, I wish I'd put a slide together, I could totally give a 1 or 2 minute overview. There's nothing to say that you can't do that. So if you have something, just let me know and we'll make some time for that. Okay, not seeing anyone jumping straight out of the screen, we can transition into a little bit of discussion, and keeping in mind that people may not be looking to divulge all of the secrets of their presentation here. If people saw something that was interesting to them and have discussion topics or questions, this is a good time. I have a list of some questions, but I want to give other people an opportunity first. So if you have a question, feel free to use your hand, or I think this is a small enough group that you can politely kind of speak up. You can also use the chat if people don't want to speak up. And maybe while people are thinking, I can ask some of the things that I was wondering. So I'll start with the poster that Sarena presented on the ISEX work. I thought that was really cool, and I think it's a nice example of some of the, I guess to some of us, it's kind of behind the scenes. For those of us who are in the atmospheric community, we don't often think about all these aspects, but I wonder whether some of that has coupled to modeling efforts, and particularly coupled modeling efforts. I know Janet and Neil and others have a lot of experience with coupled models, and I wonder whether some of the work that you've done for ISEX has found its way into model evaluation or other aspects.
So the National Ice Center uses like models for some of our other products. As far as like this research went,
I'm
sorry,
say,
Alexander's here too.
In the past, I don't think we have, but this ISEX campaign, we plan to integrate some stuff to help modeling and assessing sea ice concentration and thickness for models. So not yet, or we haven't, that's what we plan to this year.
No, that sounds great. And I think that in some ways, you guys are very uniquely positioned to provide some critical information. I see Janet has her hand up. Janet, go ahead.
Yeah, I really enjoyed seeing that presentation as well. The NOAA coupled Arctic forecast system model that we call CAFS did provide forecasts for the ISAC campaign in 2018, I believe, maybe even 2019. And although we were able to provide the forecasts, and I think that they were used, and we posted them to a website that anybody could access, I feel like we didn't quite go far past that, providing a product to reincorporating the observations so we could validate the model. So I know that's water under the bridge, but we're always interested in doing that kind of work and working with the NIC as possible as well. So perhaps in the future we could maybe reinstate that partnership and see what we can do to actually use the information in both a push and a pull. That's it.
Yes. Yeah, that's really great. Thanks for bringing that up, Janet. I'd love to get in touch with you and talk more offline about that, because that's definitely something we're interested in. So,
sounds great.
Thank you.
Excellent. Thank you, guys. Neil, did you have a comment as well?
Yeah, I just want to say at NRL with our coupled model, I know we supply output to the NIC. I'm not sure if we supply output to the NIC for this for ISACs this past ISACs. But yeah, we've been through discussions, and we're always happy to try to take it to the next level of using the observations for ISACs, or looking at our model results a little bit better. So over.
Thanks, Neil, for chiming in there. And I've actually been in touch with a few people from NRL out there recently, more along the lines of like using archive data and whatnot. But thank you for bringing that up, and we love working with you as well.
Very good, thank you. I will pause for a second before I go down my own list. I wonder if other people have reactions to any of the slides that they saw today. All right, well, I'm happy to keep going down my own list. I want to make sure I'm being as inclusive as possible here. One of the other things I was interested in, so Elise, in your poster on the INPs, it was interesting to me to see kind of the difference between the two locations and the heat sensitivity part. And I wonder if you have any kind of speculative insight into why those differences exist. I would have maybe thought it would have been the other way around, where the more southerly location has more exposure to biogenic and particles that are going to be more heat sensitive. But any thoughts on that?
Yeah, definitely. So we were also, running these filters and just constantly not seeing any heat sensitivity in the filters from the Azores. Our theory is kind of twofold. We think potentially there's Saharan dust in those samples. We definitely see dust. We see a lot of sea salt. We have SEM EDX results for some of those samples. And we do see a lot of sea salt, a lot of dust. We see organics in them too. So we think that potentially what we're seeing there is actually long range transported organics that have had time to maybe be processed in the atmosphere, versus up at Nielsen, maybe it's more local organics. But as far as I know, ENA is that first site that we've really seen just that complete lack of heat sensitivity consistently across the seasons. It wasn't, one season's heat sensitive and one isn't. Although I will put a caveat that we don't have summertime samples when you would expect to see that really high biogenic activity locally there. So yeah, maybe dust, maybe sea salt, but there's dust in the Nielsen samples too. So we're not 100% sure yet.
Yeah, that's interesting. I think it's great to see ice nucleation measurements made generally. The models continue to struggle with that topic, and I think this connects to Ellen's presentation as well, as she's looking into the future states in the Arctic and how the clouds and precipitation patterns are evolving. It seems like, what you were seeing, Ellen, is more cloud and more rain, and to me that speaks to the efficiency at which the warm precipitation processes remove water from the atmosphere versus the ice. And so the work that Elise is doing with ice nucleation and understanding how that is connected to different source regions might come into play there. But I wonder if you have any thoughts about that relationship, Ellen, in your work, whether you thought about, how all those pieces fit together and how some of those cloud changes, what the kind of drivers for that might be.
I haven't looked myself into the nucleating particles. So far, what I've looked at is tendency terms. So just what the cloud liquid tends to do once it exists within the environment, and it's just much less likely to snow now. It's trying to hold it all. So a lot of that is parameterizations that have changed. But I know, it's not my area. So the ice nucleation stuff, I believe, is just parameterized just across the board. And so having observations that can really constrain what that value should be, and especially looking at more than one site. I thought your presentation was really interesting that there were so many similarities between the two. And I'm curious, are you planning on taking data at other stations as well, or having more future expeditions?
Yeah, definitely. So I'll put a big call out there. If anybody wants a truly enormous INP data set, we actually have been able to take remote measurements during the entire pandemic. And we are using a new portable ice chamber to get measurements at a 15-minute time scale. We have 180 days of measurements from the Azores. We have 45 days of measurements from Oklahoma. And we just about a month ago started collecting measurements in Ukkivik with the idea that will actually be a 2-year project. So again, this is measurements every 15 minutes, and then we have concurrent filter measurements, which is what my AGU presentation is on this year. And we're always looking for modelers to collaborate with. So get in touch if anybody wants to chat.
Yeah, very cool. Thank you. Janet, I see your hands up. I don't know if that's still up from before or whether that's a new question. And the hand went down, so I think I'll take that to be up from before. Other questions for people? I wonder, Steve, I know some of the results that you showed we've talked about previously, but I still am fascinated by the relationship between the roughness, surface roughness, and how the wind and the ice and the ocean all come together, and the potential introduction of additional waves and things like that. So I wonder if you want to provide any more depth on that topic at this point, and to what extent you see changes in the wave structure in the ocean as we're losing ice in future climate states.
Yeah, that's a great question. That was one of the motivations for this study, the effects on marine navigation and exploration and coastal erosion. This has a lot of implications for that. We haven't coupled it to a wave model. That would be a logical next step. It would take some work. I do have an undergraduate working on a simplified wave model, more or less an empirical relationship, just to see the sensitivity and which regions are most sensitive. But if you remember the maps that I put up, the biggest wind increases were over the sort of Beaufort, Chukchi, East Siberian Sea, close to land. And those are areas that are already suffering a lot from coastal erosion problems. And then you can imagine with less ice cover and a wavier or windier climate, you can imagine how the waves would become much larger there, and potential for a lot more coastal erosion, as well as a hindrance for marine navigation too.
Yeah, totally. Other questions? Jingfeng, sorry, go ahead, Colleen.
I was just gonna go back to Ellen for a second. I'm really interested to hear, you kind of left a big cliffhanger there about the changes in the model, but I noticed in the plot you showed the gray shading around like the CESM2 was greater. And is that, I was wondering if you could just describe maybe what that plot was showing, and if that was also a change from the two updated model?
Yeah, so the gray shading essentially was just the model variability, like what range of values the model supports in that. And so it showed that there is a lot more variability month to month and year to year and ensemble member to ensemble member for cloud properties. And I saw that actually across quite a few of the different properties that we looked at. So it wasn't, CESM2 is not nearly as constrained as CESM1 was. And some of the variability I've seen, so we look a bit at surface temperatures, and I'm going to credit Steve Vavrus, I think, who was at AMS Polar this summer, and asked me a question whether or not the temperature change was good or not. Am I miscrediting you there, or is that
I
right?
remember the question. I'm still waiting with bated breath for the answer.
Well,
Tell
you'll
me.
see it in my talk, because I spent the last couple months trying to answer that very question. And to go back to your question, Colleen, is the variability in what I've looked at so far in surface observations of 2-meter air temperature seem to follow very well with the model variability we're seeing in CSM2. So, you know, it'll be a variable by variable comparison. Like, I can't just make a blanket statement, CESM2 has better climate variability than CESM1 did. But from what I've investigated so far, CESM2 is doing better in some areas.
Thanks.
All right, we are approaching the end of our hour. I wonder whether there are any other comments or questions from the group. I think there are lots of connections here to be made, and hopefully people took note of presentations they'd like to follow up with or on, and also, you know, potential for data sets that could support each other's projects. Patrick, I'll allow you to once again remind people about the survey, because I think, again, with the focus on the interface here, there's a lot of good input that could be had from this group for the town hall. And I don't know if you had other comments as well, Patrick. I just saw your screen light up. So.
No, I just, you know, my camera goes in and out sometimes based on bandwidth, but yeah, please fill out the survey. We have, we put together the questionnaire, and we're taking a lot of very nice input. Just, I guess quickly what I can say is some potential straw person recommendations of some of the things we're thinking about is, you know, that we've heard about our high latitude surface turbulent flux intercomparison working group, potential workshops that we could do, organize, including understanding how to better leverage idealized modeling to improve Arctic climate projections, including, you know, not just LES and GCMs, but also the idealized versions of those models to try to figure out how to more effectively use the model hierarchy to understand the ocean atmosphere sea ice interface. A workshop to explore what, or even a webinar series to explore what we've already done in terms of in situ field campaigns. There's lots of comments so far about we need to make sure that we're effectively using what we've done in the past. And so for us to all remember the experiments that have happened already in the Arctic over the last 40 years could really help us put MOSAiC into better perspective. So these are types of the recommendations that we're getting of some things that IARPC and US CLIVAR can do together to hopefully advance our understanding. So hopefully that was enough teaser to get you guys to come up and provide your different recommendations, but also come to the town hall either in person or virtually and provide us your feedback on those recommendations and potentially suggest different ones. Thanks.
Well, I'm interested in having in-person meetings at AGU. If anyone who is going in person is interested to meet you in person to discuss some ideas that Patrick just outlined.
Yeah, I agree. I would recommend attending the town hall, and also if anyone is interested in a more direct meeting, please connect by email or however you see fit with the other people on this call. One other thing I'll add to your comments, Patrick, is at some level for IARPC, you know, we have these monthly meetings, and they are or they can be kind of mini workshops in and of themselves if you pull the right people into them. And so for those of you who are either IARPC veterans or new to IARPC, and you are joining these meetings and you're thinking, oh, these are great, but I would really like to talk about this topic, use the survey, right? Because it's a joint CLIVAR IARPC town hall and survey. And so we will listen to the input that comes through that survey. And if somebody sees a topic that is relevant for this ice ocean atmosphere interface, we can bring the relevant collaboration teams together and even do a series of IARPC meetings on the topic. That would be great to do and kind of focus the group for a little while on a particular topic. So if you have ideas, feel free to include those in the feedback through the survey. All right, Steve, go ahead.
Yeah, just on the topic of survey, I'm just curious, how many people, the show of hands, how many people are going to AGU in person? This is a strange year. I'm not, but so it looks like maybe half or so from our group. Okay, I think it looked like roughly half and half from the latest email I saw.
Yeah, I don't know how many of the people who didn't raise their hand are going to AGU at all. It's a little bit tricky with this sort of a group, but we'll see what it looks like, and hopefully both the virtual and in-person experiences are good ones. Drew, Colleen, anything to wrap up?
Nothing for me, just another thank you all for presenting. That was awesome.
I'll just echo Colleen and Heist. Thank you everyone so much for joining. I will be posting the link that Patrick has provided to the survey on the webpage, along with the information about the informal town hall that Radiance is putting together. So please send those links to your colleagues that might not have been able to make it today. I think input on both of those fronts would be greatly appreciated. The recording will be uploaded in about a couple of days, not exactly sure when, but thank you very much, everyone. This was a great series of presentations.
Yep, thank you all. Talk to you soon.
Thank you.
Thanks. Bye.
Bye.
Cheers, everybody. Bye.
Thank you.
Bye.
Bye.